Today, we are diving into a really high-stakes debate that's happening in a field that, quietly powers pretty much our entire world: statistics. With these massive AI models popping up everywhere, the whole discipline is being forced to ask some really tough questions about its own future. So let's get into what's at stake here. And really, it all boils down to this one pretty provocative question. I mean, when AI can build models with 1 trillion parameters, and you can think of those as just tiny little decision-making knobs that just work, what happens to the people who've spent a whole century building the science of data? Are they basically being replaced by their own creation? And look, this is not some abstract academic debate happening in an ivory tower. This is a real, super urgent conversation. The source for this whole explainer is actually a transcript from a packed town hall meeting where the leading minds in statistics all got together to figure out their path forward. You can just feel the energy in that room, and it tells you everything you need to know about how important this is. Right, and this gets to the heart of the identity crisis. The incredible success of these enormous AI models, which are often built with this engineering first, ask questions later mindset, seems to just defy traditional statistical principles. Things like simplicity and being able to explain your model. And that forces the entire field to ask a really fundamental question. What is our purpose now? So to really get a grip on this, we've got to understand the fundamental tension that's at play. It's really a clash between two totally different ways of thinking about the world. One of the panelists called it the two cultures of data analysis, and I think that's the perfect way to frame it. So on one side, you have traditional statistics. It's all about mathematical rigor, beautiful, elegant proofs, and making simplifying assumptions so we can actually understand the world. But on the other side, you've got modern AI. And that is all about utility, massive scale, and just raw predictive power. It's a culture that basically says, hey, let's just make it work first, and we can figure out why it works, maybe later. Panelist Eric Zhang, whose comments, by the way, were described by his peers as solid gold, he framed this choice just perfectly. Does the field cling to its traditional identity and its old ways of doing things? Or does it evolve and embrace the messy, complex reality of modern AI? That's really the question at the heart of this whole thing. Okay, so faced with this massive challenge, what's the solution? Well, the panelists laid out a two-part response. And the first part involves a really fundamental shift in how statisticians actually do their day-to-day work. This image here, which is taken directly from the source material, is basically our roadmap for the rest of this. On the left, you can see the cultural and practical shifts that are needed, and then on the right, you see the changes needed for the entire ecosystem. We're going to focus on a few of the most important pieces of this, starting with that shift in practices. First up, there's this big move from just contributing one little method to owning the entire process, end to end. As you can see, this means getting involved right from the beginning, from generating the data to cleaning it to feature engineering, which is just a fancy way of saying creating the right inputs for the model, all the way to the final deployment. It's about becoming, for lack of a better term, a full-stack data scientist. And this slide illustrates the second, and maybe even more important shift, a change in what the field actually values. Historically, right, all the prestige, all the glory has been in model work, creating cool new algorithms. But in the AI world, the data work, that messy, unglamorous job of cleaning and preparing data, is just as, if not more, important. And as panelist Pramod Mukherjee pointed out, this is a huge cultural hurdle. Everyone wants to do the fun part of building the model, but the foundation of any good AI system is incredibly well-curated data. I mean, the success of projects like ImageNet, which required hand-annotating millions of images, proves this point beyond a shadow of a doubt. And if you want to know why this data work is so critical, just look at this number. Panelist Zihong Lin highlighted that a staggering 86% of major genetic studies have been done in people of European descent. That creates a massive, massive bias that's baked right into the data from the very beginning. And the consequences are just dramatic. As this chart shows, a genetic risk model that's trained on that biased data sees its predictive accuracy just plummet when you apply it to other groups. It drops to around 50% for Asian populations and just 25% for African populations. This is a literal life or death example of why the quality and fairness of your data matters so much more than the sheer size of it. Okay, so if the work itself is changing this dramatically, then the training has to change with it, right? And that brings us to the second part of the solution: how we prepare the next generation of statisticians. Brahmar Mukherjee proposed this really simple but powerful framework for modernizing training programs. She focuses on what she calls the 3 Cs. It's no longer enough to just be a math whiz. You also need excellent communication skills. You need to be able to do deep collaboration with other fields, and you need to have powerful computation skills. And what that means is going way beyond theory. Future statisticians, they need to be fluent in the actual tools of the trade, cloud platforms, software engineering best practices, and the ridiculously complex architecture of today's machine learning systems. At the end of the day, they need to be builders, not just theorists.
So, after all this disruption, all this need for change, does statistics still have a vital role to play? Well, the panel's answer to that was a resounding yes.
Panelist Abel Rodriguez brought up this classic quote from the legendary statistician George Box. And the point is, the field's true value has never been just about abstract math. It's always been in its application, in using that math to solve real-world scientific problems.
And this is exactly where statistics becomes more essential than ever. In a world of these black box AI models that we can't fully explain, statisticians bring the critical tools for quantifying uncertainty, for spotting and fixing bias, for reasoning about cause and effect, and for making sure that these incredibly powerful systems are evaluated with true scientific rigor. These aren't just nice-to-haves. They are absolutely crucial for building AI we can actually trust.
But to make that impact, they have to adapt. Panelist David Donahoe offered this absolutely stunning analogy. He said, a statistics legend like R.A. Fisher today is like Mick Jagger standing in a crowd of young people who are all just glued to their phones. The legend, the rock star, is right there in front of them. But for this new generation that consumes information in a totally different way, he might as well not even exist.
Which leaves us with this final and, I think, really profound question. This whole debate over statistics and AI, it isn't just about jobs or methods. It forces us to reconsider what knowledge even is. If an AI can predict the world perfectly, but can't explain how it does it, does that count as understanding? And maybe more importantly, what is the human role in a world like that?